So this is an example of Sugano's model, and you have three rules here, as I've just explained: R1, R2, and R3, and the output is K1, K2, and K3. And these rules, the first rule has an OR operator, the second rule has an AND operator, and the third rule has a single antecedent. The value in the bracket is the membership values that you have determined from their membership functions respectively. So you take the max of the membership values in the first rule, and that is the value that you get, and that is the membership value for your output K1. Similarly, for second rule, you apply the min, which is 0.2 of X and Y, and you get the membership value for the output K2, and similarly the membership value for output K3. And then you simply take the weighted average of these three outputs. This is from rule 1, this is from rule 2, this is from rule 3, and here you take the aggregation of all the rules, and this is where you calculate the final output. If the value of K1, K2, K3 are given as 20, 50, and 80 respectively, you can find out the weighted average by this very simple formula which is given here. So the membership value of input 1 into of output 1 into output 1 plus same for output 2 and same for output 3. So symbol terms के अंदर ये sigma mu I, where I is your output, times ki, ठीक है, where you have the ith output divided by the sum of the membership values. Okay, and this summation is over 1 to I. ठीक है, so this is primarily the formula. Weighted average mu की value उसी तरह से निकालते हैं जैसे ममदानी मॉडल में निकालते हैं, लेकिन the difference here is that K is a singleton. So you can see that these membership functions are not triangular or trapezoidal or of any other shape. They are a straight line. The straight line membership functions are primarily representing constants, and they are called singletons here. Okay, so this is a singleton membership function that you apply. Okay, this is another type of model that is used in fuzzy rule-based systems. This is called Suka moto model, and इसमें you can see that the output functions are either monotonically increasing functions or decreasing functions. ठीक है, तो जो ममदानीज मॉडल है उसमें the output is fuzzy. ठीक है, तो ममदानी मॉडल में आउटपुट आपके पास ट्रायंगुलर होगी या गॉसियन होगी in case of Mamdani's model. In case of Sugano's model, you either have constant output in the form of a singleton or a polynomial is represented, and in case of Suka model, you have monotonically increasing or monotonically decreasing functions. Okay? So these are the models that the shapes of the membership functions of the output. So output के membership function की variation की वजह से you have all these different models. The rest is exactly the same. So the antecedent part जो आप calculate करते हैं, that antecedent part is exactly the same. So this part here is exactly the same in all models. लेकिन जो output part है, the calculation of the output part actually varies a lot. And again the weighted average is calculated. तो फर्क सिर्फ output के अंदर आता है. The rest is exactly the same. ठीक है जी. Okay, so let's just talk about so here is another example, and this example is is from another real world problem. Um so this is the description of the problem that is given on the slides. Uh, then the system description is also given, and here the linguistic labels and their details are given. ठीक है जी. Um, and this is exactly what how a given problem is solved. So this is the description table and the details. आपके पास एक variable जो आपके पास आ रहा है, that is mean delay, which is represented by m, the number of servers, which is represented by s, repair utilization factor, which is represented by rho, and then you have the number of spares, which is represented by m. ठीक है. और इनकी linguistic descriptions आपके पास ये दी हुई हैं of all the variables, और इनकी values की ranges भी आपको दी हुई हैं. These are the value ranges, these are the notations or linguistic descriptions. ठीक है. You should go through this example yourself. यहाँ पे membership functions की shapes दी हुई हैं, and you can see here that the membership functions are not uniform in nature. ठीक है. So they are representing different ranges. For example, RS जो है of number of spares, the membership function for RS is primarily from this in this particular interval, whereas S spares का जो S है, that is in a different order. ठीक है. वो एक different range को represent कर रहा है. So this is representing S and this is representing RS. ठीक है. और इनकी डिस्क्रिप्शन जो है वो पिछले टेबल में दी हुई है. सो यू कैन ऑलवेज रेफर टू दैट टेबल एंड फाइंड आउट कि इनकी डिस्क्रिप्शन क्या है. ओके, हियर इज द रूल बेस दैट यू हैव गॉट, एंड then you can like use this rule base, implement this rule base in some tool, or implement this rule base in some programming language, and then solve this problem. ठीक है. So you can go through this example in detail and find out कि आप linguistic descriptions आपने कैसे define करनी है and all that stuff, right? Okay. Matlab provides an interface of implementing the fuzzy rule-based systems, or if someone has got access to Matlab, they can actually find out that. Here are the screenshots. It provides you with a graphical user interface to enter your fuzzy inference system or fuzzy rule-based systems in it. This part is representing the inputs. You can add more inputs here. You can add the shapes of the membership functions. Each membership function की shape जो है वो आप इसके अंदर add कर सकते हैं. Then you can define a rule, either using the AND method, OR method, implication and aggregation, either using AND or OR method, that is the connectors between the inputs. Then the implication or the inferencing mechanism. आप Mamdani's model या Sugano's model आप कर सकते हैं. The way you want to aggregate your outputs, you also can apply that. Mamdani's model के अंदर output को आप मैक्स या यूनियन लेके एग्रीगेट करते हैं. सुगैनो के अंदर डिफरेंटली एग्रीगेट करते हैं, वेटेड एवरेज लेते हैं. और अगर आप ममदानीज मॉडल यूज कर रहे हैं तो डीफजिफिकेशन प्रोसेस को भी आप डिफाइन कर सकते हैं कि आपने सेंट्रोइडल मेथड यूज करना है या कोई और मेथड यूज करना है. So the complete rule-based system can actually be done. So these are the screens that are showing you कि आप किस तरह से membership functions को change कर सकते हैं. Input membership functions, output membership functions, उनकी ranges आप define कर सकते हैं. Universe of discourse आप define कर सकते हैं. Here is an interface जहाँ पे आप rule base को add कर सकते हैं. So you can add a rule here once you have defined all the inputs and the outputs. So you can define the rule in this particular through this particular screen, and this is the interface that gives you the depiction of all the rules. So this is rule number 1. This is rule number 1 here. This is rule number 1, and then you have rule number 2 here. Then you have rule number 3 here, and then you have the final aggregated output of this rule. ठीक है. तो अगर input आपकी let's say ये है, तो आपके पास सिस्टम की डिस्क्रिप्शन आपको यहाँ पे दी होगी, एंड फ्रॉम हेयर यू कैन एक्चुअली डिटरमिन द वैल्यू ऑफ योर आउटपुट. सो अगर आपकी इनपुट 1 ये है और आउटपुट इनपुट 2 ये है, तो ये आपकी आउटपुट जो है वो दैट इज रिप्रेजेंटेड है. सो यू कैन सी यहाँ से द येलो पार्ट इज एक्चुअली रिप्रेजेंटिंग कौन कौन से रूल्स कैसे कैसे फायर हो रहे हैं. सो यू कैन सी कि इनपुट 1 पे जो आपके पास एक्टिवेशन आ रही है वो ये है, इनपुट 2 की एक्टिवेशन इन रूल 1 ये है, और फिर रूल 3 के अंदर इनपुट 2 की एक्टिवेशन आ रही है, वेयर एज द अदर रूल्स आर नॉट, द सेकंड रूल इज नॉट बीइंग एक्टिवेटेड. And then the blue part is primarily representing the output activations, or final aggregated output and defuzzified output is represented by this graph. Okay, so आप control surfaces भी define कर सकते हैं. Control surfaces are primarily representing transitions between rules. So rule 1, rule 2, rule 3 अगर आप combine करते हैं under a given input scenario, so how is the transition taking place? So this surface plot is primarily representing the regions in which different rules can be applied. So you have this plateau here, this plateau region here, and then you have this region here, and then you have got this region here. So these are primarily representing 3 different regions जिनके लिए आप rules आपने define किए हैं. So this may be representing rule 1 or rule 2 or rule 3. Similarly, अगर ये rule 1 को represent कर रहा है this shape, then rule 2 हो सकता है ये region हो, और rule 3 हो सकता है ये region हो. So what is the surface plot? The surface plot is primarily a 3D representation or a 3D graph between all your inputs, between your inputs and your output. Why 3D? क्योंकि इस केस के अंदर आपके पास input 1 और input 2 हैं और output है. It could be the surface plot could be more complex अगर आपके पास number of inputs ज़्यादा हो जाए और number of outputs भी ज़्यादा हो जाए, and again you will have some visualization issues. तो आप control surfaces draw कर सकते हैं between any given inputs, 2 at a time, and 1 output. तो आप उसके दरमियान control surfaces draw कर सकते हैं. So here is a mechanism where you can use define a .fis. .fis files are created, or .fis. FIS here means fuzzy inference system. So fuzzy inference systems को आप एक simple code भी कर सकते हैं using a simple text file, और फिर आप fuzzy rule based system के तरफ से upload कर सकते हैं. There are other ways of implementing the fuzzy rule based systems, and that is through Simulink. Or Simulink is also a tool that comes along with Matlab, or this provides you a drag drop environment जहाँ पे आप blocks को drag कर सकते, drag करके उस environment में ला के you can connect them together and then implement a standard rule based system. ठीक है जी. Okay, so this actually in a way completes our discussion on fuzzy rule based systems. So I'll the next thing that we'll be discussing is अच्छा इसमें what do you think is the main step? The main step in developing a fuzzy rule based system is number 1, that you have to define all the linguistic labels and linguistic details. So fuzzification of your variables is something that is very, very important, and without that you cannot actually proceed. One thing. The second thing is, okay, once you have the fuzzy description of all your variables, the next thing is that you will have to define a rule base, और rules को identify करना पड़ेगा आपको. ठीक है जी. Rule identification and rule implementation is required in case of fuzzy systems. ठीक है जी. So these are the 2 very important things. So I hope अब अगर आपको एक कोई problem दी जाए, description of the problem दी जाए, तो you should be able to represent it in fuzzy form and do some sort of inferencing on it to get the results manually भी, और आप अगर उसे कोड करना हो तो आप कोड भी कर सकते हैं. ठीक है. I hope you have that level of information now. Ji, so before we move on, are there any questions on what we have discussed so far? अगर कोई question है, so you can ask me now, or before we start with uh, the hybrid models in fuzzy, where we'll be combining fuzzy with neural networks and genetic algorithms, and we'll try to automate the system. Right. So, what do you think is the biggest challenge in developing a fuzzy rule-based system? Okay, so I'll just go to that. Um, the biggest challenge in any fuzzy rule-based system. G. Okay, so let me just ask someone to actually shed some light on this. In your view, what is the biggest challenge in implementing a fuzzy rule-based system? Okay,